All right, let's look at the Poisson probability distribution. This one's kind of interesting, kind of short and sweet on this one. So on this one, the distribution is like this. The definition is that the average of something occurring per amount of time is given or assumed. It could be the number of, say, bacteria in a vial. Well, that's not time. That's just what it is per volume or per area. Could be specks on a window that comes off an assembly line, whatever. Could be number of car accidents in an intersection per week, that kind of stuff. So that's given or known. The distribution is called the Poisson probability distribution. What else? I'll make sure I got all the details. Okay, probability of k occurrences of this event is given to be this. Okay, that's some fancy derivation, I'm sure. So what you expect is the average. Like that's the expected value using the other terminology. But what if it deviates from that? So if the probability of number of car accidents per week is 2 in some intersection, then what's the probability that none will happen? What's the probability that 5 will happen, right? That deviates from that mean in a certain time period. And you just use that formula. So let's just look at an example. Oh, and then the other thing interesting too is the mean. Well, that's given, so you know it has to be mu. And it isn't necessarily a sample, so you are calling it mu. The standard deviation is the square root of mu, which is interesting why that happens, but we're just going to calculate the probabilities. So here's an example. Suppose there are an average of 2 shootings per week in a certain part of Chicago city limits. And then let X be a Poisson random variable for this situation. So that's the average. So we want to know, well, what's the probability of having more or having less or duration? First question was the probability of 4 shootings in 1 week. And let me go over this formula again. Okay, so the formula for k events of something would be mu to the k e to the negative mu over k factorial. K ranges from something not occurring to however many times it would occur. If you take a limit as k approaches infinity, you'll get 0, by the way. Like it eventually can happen. Like, the probability of happening 2 million times, well, that's pretty low. Like it's just not going to happen if the average is 2. That's the idea. All right, so then E is the mathematical number. The number 2.71828. 0 factorial, remind you that is 1. And e to the x is e to the x. Okay. That is a formula that you'll use on your calculators, your scientific calculators. So we'll go over that too. Do something real quick. Okay. Here, let's continue. So let's just plug in the values for A. Okay, so we know mu is given. Mu is given to be 2 per week. We're looking for probability of k equals 4, or 4. So x is 4 shootings. And let's do the calculation. So the probability that x is equal to 4 is equal to, let's do this calculation. So it would be mu is 2 raised to the 4th, and then it's e to the negative mu, which is 2, all over k, which is 4 factorial. And I would simplify this because that's kind of what I do. So that is 16. And then that negative exponent brings it down to the denominator. So it would be e squared. Then 4 factorial is 4 times 3 times 2 times 1. So you can see here that you have a 4 and a 2 will reduce that 16. That's 8. So it'll be, so 16/8 is 2. So it'd be 2 over e squared and then times 3. So let's move this over here. So it'll be 3 right there. So that's reduced in exact form. And let's do that calculation. I'm going to move everything over so I can fit it in there. I'm a bad habit of doing that and not starting all the way to the left. Okay, so that's equal to, now we get our calculators out and do that calculation. So you get, however you want to do it, the e to the 2 is this button over here. It's e to the 2. So you hit 2 and then e, or vice versa. Mine is a little different, so e squared is 7.389. So I get 0.09. 0.090, if you will. And then 22352216. So just 3 to 4 decimal places is usually good enough for our purposes. Okay, so that's probability of 4. So what was the original probability? So 2 occurrences in a week. So the probability of 4 occurrences happening would be 0.09. Okay. Let's continue and do the next one. B. Well, there's probability of at least 1 shooting in 1 week. So probability of at least 1 would be 1 or more. So x would be greater than or equal to 1. So that like keeps going forever. So what you have to do here is do 1 minus the probability of it not occurring. So it's 1 minus probability that shooting does not occur. It would be that. So let's do that calculation. And remember, when 0 factorial is 1. Okay, so that's equal to, this case, where was it? Where's my formula? There it is. So it's 2 to the 0, which is 1. And then e to the negative 2. And then 0 factorial is 1. So you're really just calculating 1 over e squared. And then you do 1 minus that. So let's do that calculation. So, but you can do e squared and then the 1 over if you wanted to. So e squared is 7.38, etc. And then you do the 1 over that button, and you'll get 0.135, etc. And then you subtract 1 from that, which is 0.864. So this is equal to 0.864, and I'll go and write in 66, and then etc. So basically 86% chance that a shooting will occur. More than one or more would occur is basically what that's saying. So you're basically saying that there's an 86% chance that you will have 1 or more shooting in that general area of Chicago. There are cumulative tables and ways to calculate this for binomial and Poisson, which is just this calculation. I'm just going to have you do a specific one or do the 1 minus to get just maybe one or two of them. So if you calculated maybe two or more, then you have to calculate probability of, let's just say two or less. So you have to do each individual case. So if you do the probability of, say, x less than or equal to 2, then that's the probability of x equal to 0, plus the probability of x equal to 1, plus the probability of x equal to 2, because it says equals. So you just add them all up. But I wouldn't have you do a bunch of them. That's it. The cumulative tables always assumes it's cumulative all the way up. Like it adds those up automatically, and then you have to subtract to find the middle cases, which try to look at that on your own this week, and then we'll get to it probably more carefully for normal distributions.